Hello and welcome to my channel. My name is Brianne Beebe. I am a high school geometry teacher and I teach with interactive notebooks. And this is our next unit in the Geometry Interactive Notebook Flip-Through. So we are now on a volume, and once again, I'm actually currently teaching this lesson as I film, which is very exciting. So I can show you what my current notes look like. Now this unit is actually going to appear differently from what I have available on Teachers Pay Teachers. That's because this unit is so heavily tested on our state exam that a lot of the notes that I use with my students are including state exam questions, which I cannot put up on Teachers Pay Teachers and claim as my own, obviously. So I have different notes, like the notes are the same overall, or they will be because I'm going to update them, but the questions will be different. So just letting you know in case you go click at any of the links below and want to purchase any of this, it's going to look a little bit different. So before we start with any of the content, I give my students formulas for perimeter and area of the basic shapes. These are formulas that they most likely have already encountered. Maybe they know them, maybe they don't, but I go over everything with them. So we have perimeter areas for rectangles, squares, and triangles. Those are like the main shapes. And then we have the circumference formula for circles as well. Then we also have the area formulas for each. And on this page, I'm just breaking down like what the different parts are. What's the base? What's the height? What's the side? What's the radius? It's all explained on here for students. Then the next page is a scaled down version of the reference sheet that is given on our state exam. So students get to see exactly what it is that they'll get when they take this test, because the formulas will be given to them just like on our state exam. So we go over which formulas they need to use. My state has one reference sheet for all of the math exams. So there's stuff on here that my students won't need from Algebra 2, but I show them what they do need for geometry. So on the first day, we go through the formulas and then we start with area and perimeter. So these are just really basic questions. We have find the perimeter of an irregular figure that's based on a rectangle shape. We have find the circumference of a circle, perimeter and area of a triangle. So we get to talk about the difference between the sides of the triangle and the height of the triangle. Then we have an area of a square problem where they actually give the area and students have to find the length of a side. We have find the area of a circle given the diameter. Then the last question on this page is an algebraic area of a triangle question. On the inside, we have all state exam questions. So some of these are a little crazy, a little bit different. My state asks about population density as a geometry question because it involves area. So I actually have to explain to my students what population density is and how it works. So we have those questions in there. So like I said, these are all state exam questions. These are the harder ones, so I get to go over them with my students so that way they're not getting faced with questions like this on like a test or quiz or practice. So they're not on their own for these. These ones are a little crazy. The next day we get to do solids, which is just about the 3D shapes. So I talk about naming different polyhedra, the prisms and the pyramids, how it's based on their base shape. And then we talk about rotating two-dimensional figures. This is always a little bit painful to teach just because it's a visualization and students either understand it or they don't. So I have a video that I will link below that I show my students every year because it shows a 2D shape rotating and how it fills in as it goes about. And some students just don't get it and they have a hard time visualizing. So that video is so super helpful. And I also found a GeoGebra application where students can play with the shapes and see how it fills in there as well. It's not the same visually. The video is my favorite visual, but the GeoGebra is also really helpful. So that will be linked below as well. Then we do cross sections. So I explain cross sections to students as taking a slice of a 3D shape, and the question is, what 2D shape is it on the inside? So I try my best to explain it with some examples, and once they kind of understand what it is that we're looking for, we do my favorite part of the lesson. We play with Play-Doh. So I have my students make a cylinder, sphere, rectangular prism, and cone as best as they can out of Play-Doh. And then I give them fishing line, basically. Have them hold it really tight and slice through the Play-Doh. And I'm telling them, you're looking at what is the shape on the inside when you slice it. I also explain to them when you sculpt with Play-Doh, you're not getting perfect shapes. So you might open up your Play-Doh shape and kind of not recognize the shape that it's making. But I tell them to be in the frame of mind of, if this was perfect, what would the shape be right here? And that's been super helpful. So they investigate what the shape will be if the cross section is parallel to the base, perpendicular, and then just for fun, they won't ask on our state exam, but I put what happens if it's skewed to the base, and that starts a lot of fun conversations. Then after solids, we start talking about how to calculate volume for different shapes. So what I notice people typically do is they will pair together prisms and cylinders for one day, and then they'll put together cones and pyramids the next day. I decided I don't like it that way. Instead, I combine together prisms and pyramids the first day, and then we do cylinders and cones the second day. So the thing with prisms and pyramids is that we give our students the general formula, volume equals base area times height, where they have to replace the base area formula or calculate it separately. And I explain those strategies to them, but we go over what is the volume of a rectangular prism, the volume of a square prism, the volume of a triangular prism, so that they have like those formulas there and they refer back to here. And we talk about how to replace it when they have to do some of these problems. So I go over with my students what would the formula be for a rectangular prism, a square prism, a triangular prism, and we figure it out right here together, and then we go over some examples. After the prisms, we talk about Cavalier's principle, and this does go well if you are pairing together the prisms and the cylinders, because it only applies to prisms and cylinders. So we go over Cavalier's principle, how it works, and we have a state exam example here that we work with. And then we go on to volume of a pyramid. So because of the way that the formulas are, where you have to replace the base area, I like doing prisms and pyramids the same day. And then we get to talk about how it's the prism formula, it's just 1/3 of a prism. And then on the last part of this, the inside page, we have some examples, including some examples from our state exam. And then the following day, this is what we just did. Today we have volume of cylinders and cones. So again, I like to explain the formulas. They are the same. The base area is pi r squared, and the difference between the cylinder and the cone is using the 1/3. So we have that, and then we have some examples. Then the following day we have volume of spheres. I leave spheres by itself, although it would be nice to pair it with cylinders and cones. It's just a lot for one day, so I like to do at most 2 shapes per day. So we have volume of spheres with some examples. And then our last topic is similar solids. So we start out with a little like discovery piece, and I don't limit it to just solids. We also go over the similar figures here as well. So I give them a pair of rectangles and we talk about finding the scale factor between them because they are similar. We find the perimeter of each and the area of each, and then we find the ratio of their perimeters and their areas. Then we do the same thing but with rectangular prisms. We determine their scale factor, and I make the scale factor too. I keep it really simple. And then we calculate the volume of both prisms, and then we find the ratio of the prisms, and then that leads us to the theorem about the ratio of their perimeters, areas, and volumes of similar figures. And then we have a couple of state exam questions that we practice here. That is the whole unit on volume. It feels like there's not a lot there. We do get through it pretty quick, but we also take time to practice more of the state exam questions because they throw in a lot of extra twists. The other thing that I do is, because the notes are pretty short, I give my students practice activities after we finish the notes. So we'll do the notes, and then I have a pixel puzzle for all 3 volume lessons that we do. So that helps them just practice the basics. But that is everything that we do for this unit. If you have any questions, please don't hesitate to ask, and make sure you check out the description box below where I link everything that I have and that I shared about for this unit. As always, thanks for watching.